Big M method is left now for your LPP, linear programming problems. So dual simplex method is all about minimizing stuff. So in minimize, it should be always less than, because we have to make it less. We have to minimize. We have to make it lesser. Like we have to make it minimum. But these two are greater than symbol. Like they are maximizing. So we have to treat them. Okay. That's the problem. So if we multiply them with a negative sign, which is obviously opposite sign of them, like their signs would reverse, get opposite, then the sign equality signs would be opposite. Like if 4 is greater than 3, then if then minus 3 is greater than 4, because the rules of greater than differs when signs are changed. Like more the negative number, the smaller it is, while it is the reverse in positive numbers. More the greater the number, uh, greater the value of the digit, greater the number. So it is totally opposite. Okay, so let's do this first. Also, let's first do this. Okay, 3x1 sorry, minus 3x1 minus x2 is smaller than equal to 3, minus 4x1 plus 3x2 is smaller than equal to 6, while x1 plus 2x2 is smaller than equal to 3. Because it is already smaller, we don't need to change anything, because it is already minimizing. And since this is greater than, but we operate with equality mostly, so to make it greater than, we introduce our own variables whose answer we cannot get. First we assume those variables, then we gonna get answers that make them equal. First we assume them equal. So like something is smaller, then some variable can add and become equal. Like how the difference they have, that difference can be covered if we add that thing, then they would be same. So if you subtract them, it would be zero. Then there would be no difference, so they would be equal. Understand? So that's how we are introducing slack variables, so they become equals. We assume them equal, then put them in equation, solve that, and we get real equal equation. Okay, the first one gets slack variable s1. Okay, 0 s1 sorry, plus s1 plus 0 s2. First equation, so s2 won't be there, is equal to 3. Okay, plus 0 s1 plus s2 is equal to 6. By the way, I don't know what to do with the third equation, but yeah. And these both slack variables would be present in this. This would become, wait a second. Focus is going. What? Yeah. Z is equal to 2x1 plus x2 plus s1 plus s2. Here we go. Then they come to this side. Okay, so z minus 2x1 plus minus x2 minus s1 s2. By the way, this all would be 0 here. Okay, wait a second, 0 s2. The only problem is I don't know what to do with this equation. Yeah, let's just give it all S1, S2. It gets S1 plus S2 equal to 3. Here we go. Now we have to make table, okay? Z S1 S2. Now what? Where would the third equation fit? I don't get it. I totally don't get it. S1 into S2 or something? I don't get it. If any viewer knows what to do here, kindly tell me, that would be really helpful. So yeah, now we have here x1, x2, s1, s2, okay, and RHS too. RHS, and we have ratio here. Ratio, okay. So it is like simplex method, but the table is 180-degree reversed. Like rules are same, like negative, positive. In RHS for key row, previously you found key columns first. Now you would find key row first. Why? The first thing you look for is always negative thing, most negative, greater integer, that you used to do in Z equation, but now you are gonna do in RHS. So then you used to divide Z's key column to RHS. Now you divide RHS from Z and find ratio. Then in ratio, least positive number you take, like previous, like that. Then you divide it. Then you divide the key row with key element, and you try to make other zero by row transformation, row operation. That is all same, okay. In Z equation, -2, x1 is -2. Wait a second, this ink is not working. Oh boy. -2, -1, 0, 0. By the way, this is equal to 0, okay. Yeah, 0. Wait a second, focus is not coming. Yeah, so it is 0, okay. RHS is 0 because we took the whole equation from RHS to LHS, okay. So in S1, first equation, see what it is, okay. This equation, oh boy, I just erased it all. Oh my god, now this thing's gonna trouble me. Okay, yeah. -3, -1, 1, 0. -3, -1, 1, 0, 3. We took the equation this side because then otherwise it won't have x1, x2 values, and everything would come in RHS, those x1, x2 value. Now at least we have RHS 0 and x1, x2 in LHS. So that's why in Z equation we take it to other side, the RHS to LHS, okay. You got it right. So now -4 in S2, it is -4, 3, 0, 1, 6. In S1, S2, 1, 2, 1, 1, 3. Then we have to find RHS, which is negative, most negative. Wait a second. Okay, so since we multiplied negative sign here, whole should have been negative. So this is not 3, this is -3. Oh, have to change a pen marker. I have to change my marker. So this is supposed to be minus 3, okay? This is not 3. Because we multiplied whole by my negative sign, okay? We multiplied the whole equation by negative sign. Then this RHS would be also negative, right? To balance. Or else the question would change. But if RHS is also multiplied by the same sign, then it is common factor, so nothing changes. At the end, they come each other side, balance each other's. It remains the same thing. So it's minus 3 and minus 6. Greater digit with minus sign is minus 6. Indirectly, we find the smallest number in every row, but yeah. But you can remember this easily, that bigger number with negative sign. So this is our key row. And now we have to divide this with z equation to find ratio. Hmm. I guess it's supposed to be 4 by minus 2. Yeah, so yeah, it is supposed to be like that. Minus 2 minus 4 is 1 by 2 minus 1 by 3. 2 by 4 is minus 2 by minus 4 is 1 by 2, because 2 twos are 4. So 2 gets cancelled, 2 twos are 1, and 2 twos are 4. So yeah, common factor 2 is taken out, 1 and 4. Because in these both come in 2's table, so they are 2 is the common factor, and negative sign in numerator and denominator gets cancelled. Negative divided by negative is positive, like negative multiplied by negative is positive, right? It's like if you have debt and other person also has debt from you, then they get cancelled. Remember it like that, not exact thing, okay? So minus 1 by 3 is minus 1 by 3, 0 by 1 is 0, 0, wait a second, 0 by 0 is 0 somehow. We don't need to even write. 0 by 1 is 0, still don't have to write because we won't consider it. And 0 by minus 6 is still 0, we ain't writing. So minus 1 by 3 1 by 2. So which is the smallest positive number? This one, okay? So this is the key column, okay? So we have to find smallest positive number here, but only positive number here is this. So we are going to take it as key column, okay? Key column. We got key column. So key column and key row intersect at 4. So 4 is the key element. We have to divide the whole row with 4, okay? Minus 4, okay? To make this key element 1, okay? And so that it can make other 0 and we get unitary matrix at the end. That is our goal, okay? Iteration 2 z, and also these get exchanged, like x1 comes here and s2 just vanishes, okay? Because we found s1 sort of, right? x1 s2 s1 s2 something like that. Minus 2 minus 3. Wait a second, I should write that actually. Minus 4 by 4 is 1, minus 1, I guess. Wait a second. X1 should come here, okay. S1 x1. Fair. Now minus 4 by minus 4 is 1. 3 by minus 4. 4. 0 by minus 4 is this key element would divide this whole row, okay, to make this one. I hope you got it, like to make unitary matrix and other 0. So yeah, which has 1 in diagonals, at least in the middle. So 0 by minus 4 is still 0. 1 by, wait a second, what happened? Yeah, 1 by minus 4 is minus 1 by 4. Minus 1 by minus, no, 1 by minus 4 is minus 1 by 4, because 1 by minus 4 would be minus 1 by 4. Minus 6 by minus 4 is 6 by 4, which is 3 by 2. Here we go. So now we have to do row operations, like we have to subtract it with after multiplying with something, we have to subtract with each row so that they become 0, okay. So no, not everything will become 0. Like this key column elements will become 0 of each row, okay, by doing row transformation. So 1 into like minus 2, for minus 2 to make become 0, how we should add 1, like what we should multiply and add to minus 2, what we should multiply to 1, and how we should add it to minus 2 that it becomes 0. Minus 2 plus 2 will become 0, okay. So since 1 and minus 2 are of opposite signs, so I don't need to add negative I don't need to subtract them to make them clash. They would automatically clash. So to make the remain the sign same, I would just add them. They would automatically clash because they have already opposite signs. So so this row changes on the left hand side what we write. So I have to change r1, so I would write r1 here with r3. So r1 is r1 plus 2r2 2r3. So we have to use r3 to make changes to r1. So r1 would be on left hand side and r3 would be on the right hand side, and I would add, because they are opposite signs, they would reduce each other. And 2 1 comes in like 2 comes in one's table if we multiply it by 2. So we can make 1, if we multiply 2 to 1, then it becomes 2, which can make minus 2 0. So by this way we can make it 0. So that's why we are doing it, okay. Then 2 ones are 2, okay. 2 plus minus 2 plus 2 0. Wait a second, where it is? Yeah. Then 3 by 4 into 2. 3 by minus 4 into 2, okay, into 2, then it becomes 3 by minus 2, okay, like into 2, then 2 divides by this 4. 2 ones are 2, 2 twos are 4, because 2 is the common factor, we take it out, then becomes 1 by 2. Then 1 into 3 is 3, because numerator into denominator divided by denominator into denominator. See, numerator by denominator into denominator, numerator by denominator into numerator by denominator is how we multiply fractions. So 3 by minus 4 into 2 would be 3 by minus 4 into 2 would be 3 by minus 2. 3 by minus 2 added to minus 1 would be we would multiply this minus 1 by 2, then it would become minus 2. minus 2 minus 3 minus 5 by 2 minus 5 by 2 minus 5 by 2. Yeah, so it would become minus 5 by 2. Minus 5 by 2. Okay. 0 into 2 is still 0. 0 plus 0 is also 0. So it would remain 0. Now 1 by minus 4 into 2 is minus 1 by 2, because multiplied by 2, 2 and 4 cancels by common factor 2. 2 ones are 2, 2 twos are 4. Then below we get 2, above we get 1 into 1, 1 into 1 is 1. Then below is 2, so minus 1 by 2, minus goes up. It is the same thing. Minus can travel numerator and denominator, it is the same thing. So minus 1 by 2 plus 0 is minus 1 by 2, right? So we get minus 1 by 2. 3 by 2 multiplied by 2. Okay. 3 by 2 multiplied by 2 is 3. 3 plus 0. 3 plus 0 is 3. So we get 3 here. Where it is? Yeah. Now we have to make minus 3 as 0 using 1. Then we can multiply it by 3. Like if we multiply 3 to 1, it can become 3 and reduce it to 0. Since they are opposite signs, we would just add them. We don't need to subtract them to make them clash, because they are already opposite. We don't need to make them opposite signs to reduce each other. So, and we need to multiply by 3 to 1, then we get 3, which can reduce it to 0. So let's get to work. R2 is R2 plus 3 R3. Okay, R2 would get changed by R3. Okay, so now obviously this would be 0 because we are trying to make that only. Now 3R3, right? 3 into 3 9 minus 9 by 4 minus 9 by 4 plus minus 9 by 4 plus minus 9 by 4 added to minus 1 would be 4 ones are 4. This 4 would get multiplied there to make LCM, because this is 1, so 1, this is 1 by 1, so below also multiplied by 4, above also multiplied by 4 to balance the numerator and denominator and keep it same to so that we can remove the common factor next time, anytime we want. It will still stay the same. So 4 by 4, so then we would get common denominator between this and this as 4. Then they can get subtracted or added. So we get minus 3 added to minus 4. It is minus 7. Minus 7 by 4. Let's go, wait a second. It's not working. Yeah, minus 7 by not 2, bro. 4. Okay. Now we have 1. Okay. Minus 7 by 1. Now here we have 0. 0, right? 0 into 3 is still 0. Now 0 plus 0 into 3 is 0. 0 plus 1 is 1. Simple. Second 1. Now next we have 0. Next we have minus 1 by 4 into 3, minus 3 by 4, minus 3 by 4 plus 0 in S1 row, like second row here, 0. Then it would be still stay the same, minus 3 by 4. No? Yeah, so yeah, we got it, I guess. Now 3 into 3 by 2, we get 9 by 2, right? 2, 3, 9. 9 by 2. 9 by 2 added to minus 3. This is minus 3. Okay. This is minus 3 and we add it to 9 by 2. Okay. We add it to 9 by 2 to minus 3. So 9 by 2 is 4.5, then minus 3. Since we are adding, so whatever the number sign is there, it would still stay same and would get added simply. So minus 3 would remain minus 3, 9 by 2 would remain 9 by 2, and we would just add it. So but 9 by 2 is 4.5, 4.5 minus 3 is 1.5. We get here 1.5. Okay. Now S1 S2 row, for reducing one, since these are of same sign, like one, this is positive 1, this is positive 1, new uh, key element we have to use to reduce these, because they, with reference to this we are reducing them to get unitary matrix, because this is the unitary matrix we are talking about, so we would use this to make the unitary matrix. Okay, so this is 1, this is 1, nothing to need to multiply, they are same, they would cut each other, but we need to make them, okay, we need to make them clash. So they are of same signs. If we add them, they double up, but if we add minus, if we subtract them, then they would clash because signs would become opposite, and when they add, they would clash each other because they would become opposite, and reduce each other to 0, like reduce this to 0. Okay, now we got R4 is R4 minus R2, simple, because nothing to multiply, they are same, 1 and here also 1, so 1 minus 1 is 0. Okay, no, this is R3 actually, not R2. Yeah, this is R3. See, R3 row 3. Okay, 3 by my bad, sorry. So 2, okay, this is 2 minus of minus 3 by 4, so minus into minus would become plus, and you can also say that it is minus 3 by 4, so opposite sign would be 3 by 4, positive 3 by 4, negative's opposite is positive, simple. We try to change signs when we subtract, so we try to make them clash. So positive 3 by 4, 2 plus 3 by 4 is 4, would multiply by 2 to make LCM, so that they have common denominator. Whole parts should be same, so that we can take parts of it, like numerator says. So 4, 2 4s are 8, 8 plus 3, 11, 11 by 4. Okay, 11 by 4. Why I feel like this RHS would be negative? Okay, whatever. So 0, 1 minus 0 is 1, this 1, this 0, minus nothing changes, 1 minus minus plus, so 1 plus 1 by 4, then it is 5 by 4, like it would be 4, like it is a complete 1, then it would become like denominator because it is a complete piece. If there is some number, then it would be multiples of denominator, because like if total cake is 1 and we took some parts of it in numerator, then if there is a whole number, that is the whole cake, means that is a whole complete cake, and if there is a number, then it is any number into 1, so it is any number into whole cake, so there are that many cakes. Okay, that's how you would understand, right? I guess so. So wait a second, where are we? 0, 11 by 4, wait a second, what, plus 3 by 4, plus 3 by 4, 2 by 2, 8 plus 11, this is 0, 0, minus 1, 1 minus 0 is 1. This is minus 1 by minus 1 by 4, minus 1 by 4, so plus 1 by 4, 1 plus 1 by 4 is 5 by 4. Now 3 by 2, okay, 3 minus 3 by 2, okay, 3 minus 3 by 2, so 3 by 2 is 1.5, 3 minus 1.5 is 1.5, because 1.5's double is 3. So obviously when you uh, take half of something, or when something is double you take 1 from it, they are the same thing, because double 1 from double is like half from 1, they have common multiple, so yeah, they are the same. So other part is equal and remains the same, so yeah, we got 1.5. Since this RHS is totally equal, totally positive, our first rule for finding key row was having negative integer. Now we don't have negative integers, so the sum is over. Have fun, chill. Okay, so when you find x1 is 1, okay, then we found nothing else. Okay, x2 is I guess minus 3 by 4 or something. But yeah, you understand, right? The sum is over actually. So you can take the notes, I guess. Screenshot, take screenshot, notes. Wait a second, let me focus on the camera. Yay! So I hope you understood this. Thanks for watching. Like, share, subscribe. See you next time. Bye.